Hey everyone, and welcome to our lesson on translating rational functions and graphing f of x equals a over x, which are our rational function pictures. First, we're going to talk about translations. A vertical translation, which is a translation in the y direction, moving up or down, is going to be caused by numbers that are added outside of our operation of 1 over x. So you can see some examples here. If you see something where you've got 1 over x plus 4, that would be a vertical translation. And you also want to note that a positive number there is going to move the graph up, whereas a negative is going to move it down. All right, so this middle one here is going to be another example of a vertical move, and this time it's moving the picture down because we have a minus 1 on the outside. This one here is a little bit sneaky. The number is on the outside that's being added, but they've placed the number first. It doesn't matter as long as it's added or subtracted on the outside somewhere, then that is going to cause a vertical translation. This one is up because it's a value of 7 being added to our function. All right, thinking about the other type of movement, the horizontal translations. If our graph is moving in the x direction, left or right, that's going to be seen in the numbers added or subtracted in the operation. And when we talk about inside the operation, we're talking about right inside along with our x. So we want to look for wherever x is. Any numbers added or subtracted there are going to cause the left and right movements. So if you see a positive number there, that is actually going to move your graph left that many units. So this top one is a left-hand horizontal translation, and this bottom one is going to cause your graph to move right because it's an x minus 2. Negative numbers will cause it to move right on these horizontal translations. Okay, so we're going to take a look at a picture of one of these. Recall that our parent graph of our rational function is going to have a shape that curves like this, sort of around the x and y axes. And that's because the parent graph of a rational function has two asymptotes, both at the 0 lines. So the x equals 0 and the y equals 0. An asymptote is kind of like an imaginary boundary that's sitting there like a fence that your graph is going to curve in, approach, but never actually touch that line. So there are two of those on the parent graph of the rational function at x equals 0 and y equals 0. So it's sort of like a invisible fence sitting here and there before the function's been translated at all. Now the example we can see here has been translated, so we're going to see how that affects the picture. Since the parent graph has two asymptotes on the x equals 0 and y equals 0, the new translated picture is going to have the asymptotes at new locations. So we can see here that we have a move of 3 units to the right, and the 2 outside is going to cause a move of 2 units up. So let's get a new color here and let's draw that new picture. So keep in mind 3 units right and 2 units up. So first of all, you want to go put your asymptotes on the graph at those new locations. So whereas it started at 0, now it's going to be 3 units to the right, one of those invisible boundaries, and 2 units up. So there's the other. And that'll make it easier for you to draw your graph in. Okay, so our new translated rational function is going to look something like this. It's going to curve around these 2 new asymptotes. So it's always a good idea to find those first. All right, so you're finding your new asymptotes, you're drawing those in, and then if you want to get a really accurate picture, you can go ahead and test some points. You can test some values in for x and find the matching y's. And as always, the more the better. The more points you test, the more accurate your picture is going to be. All right, so let's take a look at this second example. 2 over x plus 4 minus 1. Now don't let this numerator throw you off. Any number over our x is still a rational function. That number does not affect our translations at all. That number is actually, we're going to see later, affects the stretching and the shrinking of the graph. But what we're looking for now are the translations. So I can see we have 2 here. So when we go graph this picture in just a second, we're going to keep in mind that the parent graph has moved 4 units left. That 4 is inside the operation with x, and 1 unit down. So 4 left, 1 down are our new asymptotes. So when we take a look at the graph, we're going to draw those in first. So 4 left, there, and 1 unit down. I'm going to draw those in. Okay, now, before we draw it in this time, we're going to test a couple of points. So let's write our function. Let's rewrite it on the screen. 2 over x plus 4 minus 1. Right? 2 over x plus 4 minus 1. And you can make a little xy table, and you can test as many as you like. I have tested -3 and -5 here, because one of these is on the right-hand side of my asymptote lines and one's on the left. It's always a good idea to test at least one on each side of your picture, since the picture is in 2 separate pieces. So if you plug in a -3, you're going to come out with a value of 1. So that's an additional point that our graph's going through that we have. -3, 1, let's plot that. And then if you plug in a -5 for your x, you're going to come out with 3. So -5, -3, let's find that one. Down here. Okay, so let's get a new color for our graph. So we know it's going to kind of curve around these new asymptotes. Always going to kind of hug those lines and come in closer and closer, but never crossing over them. And that side will go through that point for sure. And then our left-hand side will curve around the other way and move through the other point we tested. This concludes our lesson on translating rational functions and graphing f of x equals a over x.